Hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fashe Ochet. As you can see this structure, today we want to show you something special that is very important. Now looking at this one is for a church. They want to have a small school, and on this ground it has been sent to us by the architect for us to design. And looking at the bearing capacity of that place, we saw the need of using a beam raft. Now the question now is, how do you correct your beam raft failure when you compare the load of your structure to that of the total strength of the soil? When you compare the two, you have to be sure that yes, your soil is able to carry your structure. So in this video, we are going to show you how do you correct it and how do you identify the failure. How do you know that your structure, the load, is more than that of the soil? And if your load of the structure, total load of your structure that is coming on the soil, is more than that of the capacity that the soil can carry, then how do you now increase the strength such that it will be able to carry the load of your structure? That is what we are going to show you in this particular video. Is that okay? And I want to say that sit tight and watch this video to the end. In case you have known some, good and fine. But if you watch to the end, I bet you will not regret watching this video to the end. Thank you very much. So therefore, let's go there and see how this can be done. But first of all, let's check this structure if it has passed the design. So let's check it. Let's see the design status. It's okay. So as you can see it, you can see the beam, the columns, all have passed. So what we want to do now is to design our beam raft. Is that okay? So what we are going to do here, just watch and see what we are going to do. Thank you very much. Therefore, let's move to the next level. Welcome back. Now I've shown you this structure and I said it's meant for a school that want to have a church that want to have a school. So having explained this, we want to now see how we can now correct our beam, isn't it, our beam raft when it's failing. And not only that, first of all, we are going to have part 1 and part 2 of this, because what we want to know now is to correct the failure where our structure load is more than that of the soil. How do you now design in such a way that your soil, the load can be reduced, while your soil still, your bearing capacity value is still there? Are we together? So that we want to see how that can be corrected. The beam raft correction part 1, and the part 2 will go further to now show you some other things that need to be done when it comes to beam raft design. So that is that. So let's dive into the action. So the next thing I'll do is to click on the foundation story 0. Now first of all, let me now see that before how we came up with this, we have done the video on how to model this. So if you want to know how to model this, you need to watch our videos in Ekidel channel. So that is that. So let's move further. Now at this point, let me first of all design, and let's see, and let me explain something to you. Now once you have clicked on it, which is a beam raft, you now click on on this, and then click on, before then, this one will be unchecked, this one and this one and this one. So when you have come to this place, once you click on this, on which is a finite element raft foundation analysis, you click on it, and this place they will be like this. It will be like this. So once it's like this, once it's like this, you need to check this, and this. Is that okay? So once that one has been done, come and click on on Raft Foundation Mesh. You now click on yes. So let's see. Okay, it's coming up. So it's very important to follow this procedure. So if you follow it, I bet you when you are designing, you have confidence in what you are doing, because no solution to every problem that might come up. Is that okay? So that's that. So once you come to this place, you click on generate model. Once you click on it, you wait for it. And let's see what it's going to give to us. Is that okay? As I've said, we want to correct your beam raft failure, and we have 2 things to do. But the first one is what I want to show you, which is very important. Is that okay? It's very important. That's part 1. So the part 2, we are going to show you also how to correct the same beam raft, because there are 2 things that you need to look out for. Is that okay? So that is that. So let's see. It's coming up. Okay, as you can see it has come up. It has been generated. Generate model has been generated. So the next thing to do is to come to this place and click on and click on close. And once you click on close, it brings you to this place. So you wait for it. Okay, you wait for it to take you automatically to post-analysis processes what and report. So you wait for it to take you to that particular place. Let's wait for it and see what it's going to give us. Is that okay? Because as at that point, we are going to enter the soil bearing capacity that has been given to us by our technicians. Is that okay? So that is that. So it's now it's trying to generate it. So let's wait for it. Let's wait for it. It's coming up. So as you can see, it's coming up. It's coming up. So let's wait for it. Okay, here we are. You can see it has come up. So now at this point, we are going to enter based on the geotechnical report, and our value given to us was 48. Is that okay? Kilonewton per meter square. That's the bearing capacity that was given to us. And at this place, you leave it at default as 11. Is that okay? Once you have entered your soil bearing capacity here, the next thing you are going to do is to do what? Click on analysis post processing and click. So once you have clicked on that, excuse me, you now wait for it again to take you to the next level where you are going to do some comparison. Is that okay? So let's wait for it to come up. You can see it's loading. It's loading. So let's wait for it. It's loading. I want to take you through the process. Is that okay? Which is very, very important. Is that okay? It's still coming up. It's straight working on it. It's coming up. It's still coming up. All right, here we are. So you can see it. Here we are. So therefore, once we come to this place, the next thing we are going to do is to click on what? On standard contour. Is that okay? I click on it and wait for it. So you can see it now. So at this point, what you are going to do here, you are going to load all of this into this structure. Is that okay? We are going to load all of this into this particular structure. So the next thing I'll do is to do what? Click on load this bending moment. We have to, in this MX direction, we have to load it inside this structure. Is that okay? We have to load it. So it has come up. So the next thing, I click on the Y direction. Then let's see it to come up. To come up. Yes. The next thing, I click on this. So this is what we are going to do to all. And let's see what it's going to give us. Is that okay? The next one, I click on this. Bending moment on one direction, direction 2, and direction 12. So I click on direction 2 again. Okay. Now the next one is going to be on that of 12, which I also click. Is that okay? I'll also click on this. Then the next one, I'll click on this. I'll click on this. Let's wait for it. Okay. Let's wait for it. Okay, the next one will come up. Okay, I click on this. Also, design moment. We are on design moment now. We are on design moment. Okay, the last one on design moment, we are clicking. So as you can see, okay, at this point, which is a required steel area, this place is when your slab fail. How do you know that your slab fail? Is at this point your section is not sufficient. When it comes to slab, this is where you get to know. Is that okay? And how to correct that will also be done maybe in a subsequent video. And we already have one or so. So if there's any failure, we are going to see it. Is that okay? Okay, it's perfectly okay. The slab thickness is okay. All right, let's move further. Let's move further. Let's move on. Let's move on. Okay. Yes, click on this one, last one. Let's click on it. Let's click on it. Okay, good. Now, having done all of this, we have loaded all of this into this particular structure. Now that you have loaded it, I want to tell you that if you look at this is at worst condition, isn't it? But we also want to know our load plus factor of safety of the soil. We want to see it now compared with this load, total load of this structure. At worst condition is we are going to see it here. The value at worst condition of this load, you can see it here, and also the capacity of the soil, what the soil can carry, the load that the soil can carry. We are still going to see it at the same time here. Where my cursor is, we are going to see that one here, while this one will show that of the structure. So for us to know that, now we come to this place and click on soil pressure. Is that okay? You click on soil pressure and wait for it. Let's wait for it. If your system is slow, this one might take let me say a lot of time. If it's slow, it might take a lot of time, but notwithstanding, let's wait for it. Since you have seen I've clicked on it, so let's wait and see what it's going to give us here. Don't forget we are having 460 point what 42. Is that okay? That is that. So now let's now see, after clicking on this soil pressure and see what you see, we have what 149.601. This the total load of this structure at worst condition. You see, at worst condition, you can see 130 from here, from this 18, 37, 56, 74, 93, 112, 130, and at worst conditions, what we have what 149.6 0.01. Now this is load of the structure. Let's now see that of the soil. So put your cursor here to see. You can see as I'm putting my cursor here, as you can see it, you see 67. Now your question now will be, how do we get this 67? That's another question. 67.2. How do you get this 67 is the next question. But first of all, if you look at this, as I'm putting my cursor on these places, you can see it's telling me what is very okay. But the question now is, where is the failure coming from? Why are we having this high value here, whereas at this place is showing what, that everything is okay? So let me go to the edge of this. You can now see at the edge it's showing me warning. It's showing me warning, isn't it? At this edges is telling me what? It's showing me warning, which means that at the edge of this beam raft, the soil is trying to push the beam. How together? It's trying to push the beam, so which I'm going to show you, and how do we correct that. But first of all, let's see 149, isn't it? 149.60. Now, if you look at the soil, it's what? 67. But first of all, let me explain to you how do we get this 67. Come to this place. Let me pick my calculator. Now, let me cancel this. Now, what was our bearing capacity that we got is 48, isn't it? 48 multiplied by 1.4, which is factor of safety. So we're having what? You can see 67. So you can see we have 67.2 and also have what? 67.2. That is how we got our 67.2. Is that okay? I did it again. 48 multiplied by 1.4 factor of safety give us this. Use it now. So that is that. Now, having done that, how do you now correct this failure such that you can now rectify the soil that is trying to push this beam? How do you know how to solve it? Is what we want to do now. Is that okay? So that is that. So but first of all, let's do some calculations before we do that. So looking at this, let's know the difference between this one, this value here, and this value here. Is that okay? Let us know the difference between this one and this value here. So we have from here we have what? 149, isn't it? 0.601, isn't it? Minus 57. Sorry, 67. Is that okay? I say it's equal to what? It's equal to what? 82.601. This is the difference between this structure and this soil. Is that okay? Now, the next thing is the minimum you can ever think of is what? What we are getting here, you multiply by what? By 4. That difference is you multiply by 4. What is it going to give us? It's giving us 330. That is the minimum that you can ever start with. Is that okay? Don't forget this value, 330, isn't it? This is the minimum we can ever start with. So therefore, let's now go and solve the problem. Is that okay? So the next thing, I will close this. Is that okay? I'll click on close. I'll say cancel. I'll also cancel this one. I'll cancel it. Good. Now, don't forget we are saying our value. We said our value that time was 330. Is that okay? 330 or so. Now, what I will now do is to come to this place. Let me show you. Now, at this point, what was showing us that time was that the soil around this place is trying to push this beam. It's trying to push this beam, and as a result of that, it's causing a failure. Is that okay? You know, we have what we call active earth pressure, isn't it? So therefore, it's trying to push this beam. Since it's trying to push this beam, we are going to provide a cantilever that will resist the soil. Are you getting me? At the base of this beam, we are going to provide a cantilever that will resist this particular soil that is trying to push this beam. Now the question now is, how do I know the extent of the beam, the length of the beam that is needed to resist this soil from pushing this beam? Because if my beam slab is too close to this beam, it might find it difficult to do what? To resist the pressure that is coming from the soil. Are you getting it? But if you have a more cantilever length of slab, it has enough strength to do what? To resist the soil before touching this water, this beam. So how do we now do that? Know that length. We said we go to this place, and we said that minimum is what? We said what we have was 149, no, 149 rather, 149.601, isn't it? Let me cancel this. 149.601 minus, remember, 57 gave us this. We said multiply by what? By 4. Give us this. Is that okay? But since this is our minimum, let me show you something. Because once you put this value there and it's not enough, we have to come back and increase it. Since this is our minimum, just like assumed when you are designing your column, you have assumed section of your column. When you are designing your beam, you have assumed depth of beam. Is that okay? So now, but if you use this, there's tendency that what, it might not pass, because we are talking of what, this is the minimum you can start with. You cannot start less than this. Is that okay? But for me, from experience, I would say that you have that value. When you have that value, let me take it again, 149.601 minus 67. You know where we got all this value from, isn't it? Then we have what, this. Is that okay? Then multiply by 5, which is equal to what, this. Now, since this is my own minimum now, I'll just multiply by what, by 2, which is equal to what, 826. It's already more than approximately, I'm going to use 1000 to avoid stress. Is that okay? To avoid increasing and all of that, to go back and come back. So to avoid that, that is the best way to go about it. So having done that, let's now go back. Now, for me to now solve it, if I click on this, I want to take the property of this. If I'm taking the properties of this, as you can see it, and at this point you can see I have what, relative level of what, of 1000. So I turn it to 0. Is that okay? That's one way. Or you come back to your concrete member and pick your slab direct. Is that okay? So because if you take the property of this, you have to go to that relative level where you put 1000 and turn it to what, to 0. So that is that. So I come to this place and check everything is okay, and my relative level is what, is 0. Are we together? So come back to this place, then pick type 12 cantilever, because you want to create a cantilever that will resist that soil. So at this point, since based on our calculation, I said we are using what, our calculation is what, 826.01. So approximately I'll just make it what, 1000. Is that okay? So I'll just put 1000, use it now, 1000. Then I'll begin to do what, enter, draw my cantilever from this point to this point. Is that okay? I'll say yes. From this point to this point, put it here. This is what I'm going to do to all, and then we'll analyze and design again. Is that okay? So I'm trying to rush this. So as you can see it, we are trying to correct that. This is just the part 1 of this video. The part 2, we are going to see how do you now correct your beam when it fails. Now from this one, we are going to know at the end of this video how to correct when your load is more than the soil. So you can see it now, it's more than the soil. And the next part, we now see how we can now correct the, oh sorry, I made a mistake. Let me delete this. Let me escape. I have to delete this. Let me delete this slab. The depth is not okay. Let me quickly delete this. Let me remove this. Oh sorry. Undo it. Okay, let me remove this. Let me remove this slab. Also this slab, and also this slab. So now let me now take the properties of this property. Let it come up. Let's come over here. Then at this point, this depth, I'm using 200. Is that okay? I'm using 200. Is that okay? I'm using 200 cantilever length. This, let me check everything's okay. Okay, relatively is okay. All right. So that is that. Then I can now continue to this place. Yes. Let me confirm it. Let's confirm. It has not been updated. Use it now. It has not been updated. So let me go back. Let me click on this. Right click. Take the property, and then click on this 200 and update. Okay, that's changed. So that is that. Then I proceed from this place to this place. Enter. Okay, from here again to this place and this place. That's fine. Then the next one from this place to this place. This is what we are going to do to all. So let's take our time to do it so that you learn better. Is that okay? I don't want to pause this video. So let's see. Let's do it together. How do you correct your beam raft failure? And we have 2 ways. This is the first part. You can see that it was failing because our structural load is more than that of the soil, isn't it? So if you go ahead with that, definitely you should be expecting your structure to what? To collapse. Is that okay? So that is that. So we want to see how we can find solution to that problem, and that is what we are doing now. Is that okay? So let's see. Okay, from here again to this place. Okay, this place to this one. Okay. All right, from here to this place, also from here again to this place, also again from here to this place also. Then this is how we are going to do to all. Is that okay? I want to make it faster. Okay, just follow me as I'm showing you. Okay, all right, let's see this to this and this. Okay, now everything is done. So we are now going to close this. Once we have closed this, I close it again. Once I've closed this, let's go and see our 3D, how it looks like. Is that okay? Let's go and see how it looks like at 3D. So you can now see it now. You can see it. You can now see how it's looking. So you can see we have provided our what? Our cantilever, slab, which is used for what? In form of our toe. Is that okay? So when the soil is coming to push this beam, you can see this one is what it's going to resist the soil back, which makes this one to what? To remain stable. Is that okay now? This one is not receiving any pressure from the soil. It's not receiving any push from the soil. Why? Because this one has been provided to do what? To resist that soil that is coming to what? To push. Are we together? So that is the essence of this. So therefore, let's now go back and now see if with the help of this that we have provided, if our structure is what? Is safe. Is that okay? Click on this again and let's proceed. I'll click on what? On this. This value is still okay. Checked. Click on yes and let's proceed. Is that okay? Let's just proceed. Let's proceed. Okay, let's wait for it. It's coming up. Okay, it's coming up. About to. You can see processing, loading preprocessor. So let's wait for it. It's coming up. It's coming up. Okay, this is where we are. That's come up. So the next thing I said, just the same procedure. Click on this place and do what? And click on load generator. And let's wait for it to come up to finish generating for us. Let's wait for it. Is that okay? So it's coming up. Yes, it's coming. Very soon. It will soon be there. Okay, you can see it's reading. It will soon be there. Is that okay? Okay, almost. Almost there. So I can see 300 and 700 37, 38, 39, 4 and this. So okay, it's working on this one again. So let's wait for it. And in case you have not subscribed, this is your first time of watching our channel of our video, I want to say you should click on subscribe button and also like this video, because we are out to solve any engineering problem when it's come to structure. Is that okay? And I want to say that watching our video will also help others, in the sense that when you finish watching it, your life will never remain the same as a structural engineer. Is that okay? And I want to say also invite others. They can also what? Learn as you are also learning. Okay, it's coming up. Let's wait for it. Almost. Yes, now it has been generated for us. Is that okay? So the next thing I'm going to do is to click on what? On, close, and wait for it. Automatically on its own, it will take us to this post-analysis processes and what? And report. Is that okay? Don't do anything. Don't come here and click. Once you have clicked on close, wait for it to do what? To take you to this place automatically. Is that okay? So now what you are doing now, we are going to wait for it to come up. Is that okay? It's coming up. As you can see, it's coming up. Automatically, it's going to take us to this. Is that okay? So it's still coming up. It's trying to take us to this place. It's going to make this place what? Active. For now, this place is still active. So we want it to take us to this place to make this place active for us. Is that okay? So let's wait for it. And as we are waiting for it, there's a place in Ekidel where we have what we call a Ekidel group, whereby other engineers have come together to see that we help each other to solve each other's problem. For example, when you are designing and you have a challenge, it's a place whereby you can quickly post that. If you have joined the group, it's a place where you can post your challenge, screenshot, or you ask directly, you screenshot it and send it to that platform and ask your question before you need other engineers that have passed through same problem and have found solution to that particular problem. You quickly do what? Respond and help you solve that problem. So that is that. Now coming back to the video, we now discover that this place now, it has been made what? Active. Now the other time, what was our bearing capacity of the soil? It was 48. Is that okay? 48. So therefore, I'll now come and click on what? Analysis post processing. I'll click on it and let's wait for it. Is that okay? To take us back so that we can load our structure again and now see if this total load is more than or less than what the soil can carry. That's when we are going to know after providing that tool. Is that okay? All right. So let's wait for it. It's still coming up, so let's wait for it. It's still coming up. To still come up. So let's wait for it. Is that okay? It will still come up. And we also have Ekidel mentorship class, whereby there are other things that here we might not be mentioning, but I want to say that when you come to Ekidel mentorship class, that's the place where we train you further and tell you some further reasons why we do some things and why we don't do it. Is that okay? So once you got to this place, I believe you're already familiar to this window from the first one we have done. So the next thing to do was to click on this and wait for it. Is that okay? Sorry for that. And wait for it. So once you have clicked on it, you see all this place. We begin to do what? To load this one into the structure. Is that okay? We begin to load them, and let's see. We begin to load this. It's coming up. We have to load everything into the structure. Is that okay? Then click on the next one. Click on the next one. Okay, click on the next one, and let's wait for it. This one have to, you cannot pause this because you have to see it. As you are clicking on it, you can see the values here are changing. So click on this one again. Watch this place. This is 23.8, and as we click on this one, let's see what we are going to have. You see that is 9.9. So that is that. We are trying to load this into the structure. So therefore, let's wait and let's continue. Yes, click on this one. And the next one is this. Yes, come up, come up. The next one is this. The next one is this. The next one is this. Okay, the next one is this. The next one is this. Good. Now, from my explanation that time, I told you that if there's a failure on your slab, this is where you are going to see it. Is that okay? That's required steel area. Now, how do you correct this? That will be done in our next video. When you have something like this, how do you now correct it? And is it possible to leave it like this and proceed, or it's not possible? So all of that will be mentioned in our next video. Is that okay? So therefore, let's go further and concentrate on what we are doing. Is that okay? I click on OK and also come to the area 2, area of steel 2, then direction 2 is the same thing. Click on OK and let's proceed. Now click on what? On this, and let's wait for it at the top and also at the top. Is that okay? So let's wait for it. Good. So you can now see what we are getting here as the worst condition. Is that okay? So for us to now know that this our load at what condition is less than what we are going to get here as our soil value, what the soil can carry, we have to click on what? On this soil pressure, and let's see. Let's wait for it and see what it's going to give us. Is that okay? So let's wait for it and see what it's going to give us. Okay. Let's wait for it and see what it's going to give us. Is that okay? So let's wait for it. It's coming up. It's going to calculate it. If your system is slow, this particular one is going to take time before you can see the result. Is that okay? So let's see. Let's wait for it. It's coming up. Good. So you can now see what we are having here. So you can see that time you discover that this particular load here of this structure was more than what we are getting here. Was more than 67. But now, because we have provided the solution of that toe, which is a cantilever slab that is trying to help us push the soil backward instead of touching the beam, we are now provided that one to push the soil backward. So now the beam is stable. Are we together now? The beam is stable. So therefore, having done that, you now discover that, provided that rather, you discover that our structure, the load at what condition is less to that of what? Of the soil, which means that this soil now of bearing capacity of 48 is sufficient enough to carry this load, despite that the soil bearing capacity is very low. But based on what you have done now, your structure is what? Is safe. You can see this is how to correct your beam raft fail when your beam raft what? Fails. That's part 1 of it. Is that okay? So that is that. So the next thing you are going to do is to click on what? On close. Once you click on it, then here you do what? You click on what? OK, and wait for it to transfer all those things to what? To all this direction here. Is that okay? So click on it and wait for it. Is that okay? Let's wait for it. As you can see, transferring slab strip result, strip what? X8. Is that okay? Strip what? X8. And what's our X8? See X8 here. You can see it here. So that's what is happening now. Is that okay? So that's what's happening. So as you can see it now, we are already on what? On Y direction. This is now transferring slab strip result. Strip what? Now Y3. Where is our Y3? Let's check it. Y1, Y2. You can see Y3. It's already here transferring the loads. So you can see it. So we have to wait for it. Don't interrupt it. Allow it. Is that okay? So you have to allow it. So let's allow it and be watching it. Is that okay? So now you can see that everything has been done. It has been transferred. So once you get to this, automatically it comes to this place. Is that okay? It has finished. Automatically it comes to this place. Now, what is the next we are going to do? You can see transfer foundation beam results. If you look at this place, allow episode stress 1.4. Use now that 1.4 we multiply our value width. When you multiply your 48 multiplied by 1.4, you can see what we got, 67.2. So now, excuse me, so check with what will be on what, on this pressure. So I'll click on this, transfer foundation beam result. Once I click on it, you can now see, let's wait for it. You can see foundation beam finite element results are what? Are transferred. Is that okay? Are transferred. Automatically, I'll now click on what? On close. Now, we have finished this aspect now based on this video. Is that okay? So you can now see that our structure is what? Is perfectly okay. It has been confirmed that that soil can carry this load of this structure based on the bearing capacity that has been given to us by from our what technicians. Our soil report. Is that okay? So based on that report given to us, we discovered that yes, from what we have just done now, the soil is okay to carry this structure, despite that the place is what is a very poor area. Is that okay? So that is that. Our next class, we are going to show you how do you now get the load, the reinforcement for this. Haven't done that, it's going to be on our next video. How do you now generate your result? Is that okay? Your result, or let me just see. Okay, let's just do it. Let's see. The next we are going to do to generate your result of your reinforcement, just right click. Once you right click and come and click on what? Update. Is that okay? Click on update and let's wait for it. Let's wait for it. It's coming up. Let's wait for it. It's going to give us our results. Let's wait for it. Let us wait for it to generate our results for us. So you can see working. It's rolling. Let's wait for it. It's rolling. It's coming up. So as I said, in case you have not clicked on like button and at the same time subscribe, if this is your first time, I want to say you should click on subscribe button and at the same time like this video. You can see our reinforcement have been generated. Do you see it now? Y13 automatically is more than Y12. Automatically we are using what? Y16. Is that okay? So that is that. So you can see it's because there's a place I'm supposed to go and choose my reinforcement, which I did not choose. I believe if you watch our video, you get to see rather how to choose your choice of what? Of reinforcement. So you can see at the space of what? Of 200. So you can see all our reinforcement perfectly what? Given. Is that okay? So that is that. I want to say you should give this video a thumbs up. Is that okay? So thank you very much. Till I see you next time in our next video on the part 2 of this beam raft design, how to correct your beam raft failure, part 2. We have done part 1, whereby we have compared, we have seen this result that the soil, when this your total load of your structure is more than that of what the bearing capacity of the soil, how do you correct it? That has been done. You can now see that actually, based on the geotechnical report, we have seen that yes, that 48 kilonewton is sufficient enough because of this cantilever slab we have provided around the beams. Is sufficient enough to do what? To carry this structure. There will be no failure by the time this structure is being carried out. So you have known that part of how to correct your loads when the load of your structure is more than that of the soil. What can you do? How do you solve it? This is what we have done. So the next part is going to be part 2, where I am going to finish this up on beam raft design. Thank you. Till I see you next time.